I want some. All right, so orthogonality. So basically, this topic, when you do the question, she will just phrase the question and I will she'll give you a set of functions, right? Or a group of those functions, and she'll ask if the group of functions is orthogonal or not. So this is the first question from the tutorial. I think everybody else saw it. Let's have a question two, which is the exponential one. And it says the same concept. All right, it's the same concept of right. Everything else will just be just raw integration. Right? So with orthogonality, basically what you're trying to do, you're trying to take any two functions in the group, multiply them, integrate them across an interval, and you're supposed to be able to get zero. And if you square any function in the interval, you're supposed to get an answer that is not equal to zero. And that one will segue into orthonormal because it has used the that squared relationship to get the orthonormal relationship. So there you go. So theory, once you understand the theory, you can try to any question. Because as I said, it just go and boil down to integration. All right. So in this course, I'll give you some advice. Make sure they're real strong in integration, especially integrating tricks, because it will basically make or break you getting an A in the course or failing. Okay, if you're strong in integration, you this course, especially the Fourier and the course for next semester, it will be a breeze. If you can't integrate, however, you do real bad in the Fourier. So anyway, let's start. I'm really very tired. Right, so let's say we have a set. So you can say f1 of x, f2 of x, but I will sure give you it, f3 of x, straight down to fn of x. I'm gonna use f, I will say fb of x, or that's the end of it. So there's our set, right? This set is a function is set to be orthogonal if open bracket f of nx, which is n is a integer, a real number, by f of mx. This basically just stands for two functions inside the interval here, any two, literally any two, right? Is equal to the integral from a to b, where a to b is the interval in which they will always give you the question, because they must give you the interval in which you're integrating it across by the product of two of them, dx. And the answer must equal to 0. So basically, just go and pick two functions, multiply, multiply them, integrate them, and the answer is supposed to give you 0. You can rinse and repeat this here for part the second question. That is all you do. Pick two functions, you multiply them, integrate them, and the answer, when you plug in the interval number, you just integrate b minus a. Make sure you know that. Make sure you know it. Watch videos. Make sure you know it. When I do that integration, you will end up with 0. All right. So that's the first thing. The second one is if you integrate across the interval any function. So you can say f m of x could be anything. Put in a square bracket. Square dx. For this one, it cannot equal to 0. Yeah. So this also you could use this here. The first one is okay to prove. All right. And then the last one, which will segue into orthonormal for orthonormal sets. So the integral a to b of f, like any function, any singular function in the set, any singular function in the set, when it's squared, it must equal to 1. Yep. And the cool thing is these two linked. Why? Because, like for example, right, if you do the integration for this and you end up with pi as the answer. So because it's not equal to 0, you know it's orthogonal. If Miss was to ask you, what linear factor do you need to multiply each function by for it to be orthonormal? In your mind, you're thinking, okay, what factor can I multiply this by to end up with 1? So obviously your brain will be telling you, well, if I multiply by 1 on pi, the pi's will cancel and you end up with 1. You are very correct. But 1 on pi is not the answer. Why? Because you have these square brackets here and you're squaring it. Remember that I asked you what factor you need to multiply each individual function by. All right, so let me say you had cos 2x and you had cos 2x here. And let me did the integration, blah, blah, blah. You end up with pi. That, right? So now what you want to do is you need to add something right here so that when you square it, you will end up with 1 on pi. That is where you want. Okay, remember, you want it to be outside the integral sign. Yeah, so obviously, if I want to end up with 1 on pi, you will just use 1 on root pi. Reason why using 1 on root pi is that when you square this, you can end up with 1 on pi. So let me show you what happens. And that is the answer for majority of orthonormal questions, right? So that'd be 1 on the square root or whatever outside. It had a cancel on square, either way you take it. But I'll show you that just now. So if you add 1 on the square root of pi here, when you remove the square, up over the integral sign. So when you remove the square, when you remove square, you add a square, the square will end up with, on top of everything, right? So you can end up with the integral from a to b. This will be 1 squared, and the square root of pi squared, the square root and the square will cancel, right? So you can end up with pi cos squared 2x, yeah, dx, become a dx, right? So let me say, watch it, right? Let's say this integral from before, we had end up with pi, yeah, because when we did it here with just the cos 2x alone, you square it, you do your tricks, you end up with pi. Yeah. So this here we know is pi. So I'll write a big pi there. Pi. Because you already did it before. Right? So now obviously you can clearly see after you do your little obviously integrate already. So this disappear. So yeah, let's end up with this cancel. We're down here with 1. So all the chalala went around there. First, you do your integration for the orthonormal. You start with part 2. You will start with part 2 with the square. Just pick any function, it don't matter. If you pick this function here already, you don't have to pick another one. So you just use this one, and let me say you end up with pi as the answer. The next question will ask you what factor you need to multiply each individual function by to end up with an orthonormal set. And for orthonormal set, the answer must equal to 1. So it's basically 2, but instead of it not equal to 0, it's equal to 1. Right? So then the thought process, or go through the thought process again, carry the while to catch it. So remember you did the integration already in the blue part in part 2. Remember that. So let's say we did the integration. So I'm gonna break it down again. So let's say we did this integration here. So let me say we integrate AB cos 2x dx minus the square all squared. So that's what we have here. And let's say we did our integration and we end up with pi. Right? So we did our integration. Keep this in mind. That is pi. So now they want us to find a factor that we can multiply all the functions by to get 1 as the answer. Right now we have pi as the answer. So the second question was simple. What you need to multiply pi by to get 1? And I hope everybody and then I say 1 on pi. So you're correct. 1 on pi, you can multiply by this by pi to get 1. You are very correct. But you can't just say 1 on pi is the answer because if you multiply each function, which is this here, by 1 on pi, you're going to end up with pi squared. And you'll get the question wrong because you'll still end up with pi at the end. So I'll show you that. This is the wrong answer. So wrong. If you say the answer, meaning you're multiplying every function by 1 on pi, that means you're telling us this. Integral from a to b of 1 on pi cos 2x squared, right? So you'll do your norm dx. So you do your normal square, so you end up with AB 1 squared by pi squared by cos squared 2x dx. So I'm going through the full thing so you can see it. When you pull out the constant, which is the 1 on pi squared, you end up with 1 on pi squared integral from a to b cos squared 2x dx, right? But remember, we know what this integral is. Remember, that is pi. So if you were to make the substitution now, pi squared by pi, this will cancel with 1 of the pi, but you're going to end up with 1 on pi, which is not 1. So you get question wrong. All right, so let's do be careful, be careful. So that's say 1 on pi is the answer, so it's wrong. So what you need to do is 1 on pi, but you need to find a quick way to add in the 1 on pi by multiplying it by each function. So there's the correct way. We'll do it on this side in blue. So the correct way, so you have integral AB, you have something here, cos 2x all squared dx, right? So you want, when you square whatever you have here, you end up with 1 on pi. Real simple. You want to end up with 1 on pi when you square it. So the only way you can end up with 1 on pi when you square something, it had to be 1 on the square root of pi. Because when you square that, you end up with 1 on pi here, because remember, the square root of pi squared is pi. So you end up with this. And when you fling the 1 on pi on the other side, so you get cos squared 2x dx. And we know what this integral is. This is pi. So you end up with 1 on pi by pi, which is 1. So let's be careful. The trick is what it is used is whatever the answers is 2, it will just be 1. The factor they are multiplying it by will just be 1 on root 2. So a little equation, if it equal to a, it will just be 1 on the square root of a. So remember, when it's squared, it will just remove the square. And you get a and a will just end up canceling it, right? So, all right, it's in a sentence. You can put right in your book. So if the integral from a to b of f m of x all squared is equal to a, then the factor to make it orthonormal is 1 on the square root of a. That is what it is used. There may be exceptions, or as all things in maths, but it does work for the majority of questions. All right, if you notice it not working, then either you probably make a mistake or she trying to trick you up. And she don't want to trick you up because it's a midterm and it's not final. So you don't really have as much time as you think you do to think about questions. So they don't really bring questions that they want to bust your brain for. All right, but all in all, from orthogonal or whatever, she gonna give you a set of functions, right? Which is like this here. So I could probably go through this now. A set of functions. She gave you one, blah, 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 straight up until infinity and beyond. It really matter, right? So you have a function, we have to do is pick combinations of these functions here, and you multiplying them, integrating them, checking to see if they equal to 0. Then you will pick, if she asks you for the look at here, determine the constants by which each function must be multiplied by, or scale, however it's stated, to become orthonormal. So you pick one, you do the square, you end up with pi. Fine. Then you say in order for it to become orthonormal, it has to be 1 on the square root of pi, and you just show the proof. So you're multiplying each function by 1 on root pi or whatever it is, and you show them they end up with 1. Right? So let me try this question. Now, when do all the combinations of tricks, but that's gonna take too long, and it's just integration. It's the same thing over and over, just integration. And from last week, should be good enough with your integration, the trig component angles and whatever. That one more component angle trick I to show you. But before I start, you'll have any questions on this? Any questions? But I the idea. You multiply two functions, you end up with zero, orthogonal. A squared and it's not equal to zero, orthogonal. If they want the orthonormal, they use the square for the orthogonal. They end up with whatever answer. You have to make that result equal to 1. So you have to scale each individual function by a factor, so it will cancel, so you end up with 1 at the end. That is the idea of it. That is all you need to know. Everything else just gonna be integration. Nothing more and nothing less. Literally just raw integration. And a little bit of knowing cos 2 pi or however that will be on the graph. So you'll have any questions on it? No problem. So I clear this. I clear it. I want to do the question, right? So let me just reload the page. Right. So there you go. So when you're doing this question and you can try it for yourself and you can do all the tricks. Sure, sir. That's too much for my brain at this so I don't want to make too much mistakes. So you have one, blah, 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 blah. So the first thing, remember, when Miss give you numbers, you don't really care about the numbers. So you see in 3, 2, 1 on the city here, you don't care about the numbers because the numbers being index 1, 2, 3, 4, the dot, 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 dot means I'm going up to infinity and beyond. So you cannot use a number because if you're trying to prove something that will work for everything, you had to use letters that you could use for any number. Yeah, so you will use n and m. That is why in the proof or in the definition it had fn of x. Fm of x is equal to the integral from a to b of fn of x multiplied by fm of x dx. And that is equal to 0. So that means you have to pick two functions at different indexes and multiply them. Okay, if you pick it at the same index, it will be you doing part 2, which is going to be square. So you have to pick two separate ones. Right, so let's keep this in mind. It's two separate functions here, multiplying, integrating, and you check it to see if the answer equal to 0. That basically. So let's see what the combinations we can have in this set you have here. What I mean by combinations is, remember, you trying to show that you could pick any two functions in that set you give it, multiply them and integrate them, and you can get you any. So you had to show them for each possible combination in that set that could happen. So you have 1. So you start with the things that you could multiply by 1. So the first one you could end up with 1, comma, cos, and it could be any index of cos. So you can say n pi x on L. Yeah? Number n, it could be any number. Yeah? So if you multiply this 1 here by any of the cos's, this proof here will show that it will equal to 0. So you just say equal, and of course they give you the interval, so minus L to L. So it could be the integral from minus L to L of fn of x, which in this case would be 1. I'm not gonna write 1 to it understood, right? So it's just gonna be cos of n pi x on L dx. Yeah, and then just do your normal integration. So I'll do this one. So the differential of sinus cos, so if you integrate cos, you get end up with sine, and you have to differentiate the bracket here. So you get end up with L n pi, remember it's 1 on whatever it is. So if you have to integrate cos 2x, the differential of sinus cos. So if you integrate cos, you get sine. But you have to differentiate here. So it will be 1 on 2 sine 2x. Yeah, so just be careful with that could trick you. So since for this one, x is where differentiates with respect to n pi and L will end up being the constant. So if it's 1 on this, so it just be the same as the flip of it. So the L will just end up on top. All right, I mean, you could go ahead and do the long way, but the faster way is if you have a fraction and there's 1 over the fraction, it's just going to end up being the reciprocal of the fraction. So if you have 1 on n pi on L, it will be the same as just saying L on n pi. Right? So, I mean, that's just how I realize. If you don't want to use that, you can go through the long one. So anyway, so as I was saying, sine is cos. If you integrate cos, so it will be sine n pi x on L, and you know, it does not be pay a big square brackets minus L to L, and you plug in L, so it'll be B minus A. So in this case, B is like the L, and A is the minus L, so it'll be B. So it'll be L on n pi by sine of n pi x is L on L, subtract L on n pi sine of n pi minus L, so you could have say minus L on L, and you have that. So now we see in this will cancel with that, this will cancel with this. So you end up with L on n pi sine of n pi minus L on n pi and sine of minus n pi. So that minus inside of that sign, you can bring it out. But remember, sine is an odd function. So if you forget cos minus theta, it's just the same as cos theta. Remember, theta is everything inside of that bracket. Yeah, so don't get confused if you see two things and you don't know if it's just for the first. It's for everything. Once you're inside them two brackets, it's like theta. So just treat it like theta. All right? So this here is for even, and for odd, the minus is t. So be minus sine of theta. So if I use the same idea, when I fling out this minus here, it will disappear in here, but the minus and the minus from outside here, it will give back a plus. Right? So now we have n. Remember, n is any number. Any number. N is a number. Yeah? So this basically for this proof here, I trying to show them you can multiply 1 by any, in this case it was cos, right? You can multiply 1 by any cos term inside of the interval, inside of the function, that set of functions there, and you go and get 0, hopefully. Right? So now we have to analyze it. So we have n pi and n pi. So if you remember from sine, so that is sine, right? So this is pi, and this is 2 pi. And when if the pattern repeats itself, you're going to end up with 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. But if you notice, for all the multiples of pi, the answer is always 0. See that? It's always 0, no matter what. You can put 1,000 pi. It's still gonna be 0. 999 pi. 9,999 pi. Still gonna be 0. So for this piece here, this gonna be 0. And this part gonna be 0. So something by 0 is 0. Plus something by 0 is 0. So the answer will end up being 0. So since the integral of whatever is 0, therefore you can't put therefore it's orthogonal as yet because it just show it for 1. So what I have to do now is show it for another combination. So the other combination that I could get, it could get the 1 by a sine. So that you ought to try that same idea. So if you could do it for the cos, you could do it for the sine. So you could try it when you home. So it'll be 1 by sine of n pi x on L. So that is the next combination that I could get. And it's the same idea. So it'll be the integral, your interval that was specified in the question. 1 by anything is itself, so it's kind of redundant, right? The 1, I'll probably see it there. It's kind of redundant, right? The 1 by sine, because you're just going to end up removing it in the end either way. So kind of wasting a step. So at this point here now, we're going to do the same thing you did before. So the differential of sine is cos, and the differential of cos is minus sine. So when you fling the minus on the next side, the integral of sine will be minus cos. So it could be minus on this inside, it could be L on nx. You end up with cos n pi x on L here. So you have minus L to L. That's how I said I wasn't going to do the question. But anyway, already here. So you plug in L into it, so you get with minus L n pi cos. So go and skip some steps. When you plug L in as x in here, the L's will cancel, right? So you end up with n pi here. We'll probably see in that. Remember, L is x. So you differentiate with respect to x, you integrate with respect to x. So x is where you're plugging in the intervals that they give you. And you're subtracting, and this subtract will be a plus. Yeah, remember it's b subtract e. If this already have a subtract, when you put them together for the second piece, they will combine, right? So you're gonna put L and pi on cos, or skipping some steps, n pi. When you plug minus L as x in here, the L's will cancel. And because cos is an even function, I could fling out the minus. And it not go and change the sign outside, unlike the sign. So you just end up with n pi inside here. Yeah, so hopefully seen. If you're not seeing it, that's like so this part here, so costs are a little different in terms of the multiples. So cost does start up here and it's go up. So this here is 2 pi. Um, this here is you have pi, but in this case here, n wait. Yeah. So it don't matter what n is here. So if it's 1, 2, we end up with 1 or minus 1. Yeah, but the thing about it is that it really doesn't matter if it's 1 or minus 1, because remember, cos is an even function. It's not going to change the sign outside. How about saying that? So on the graph itself, this here is minus 1, right? And this here is 1. If it's pi, meaning that is 1. So if it's odd, you're going to end up with minus 1. If it's even, you're going to end up with 1 on top. But the thing is, this really matter. Because inside here, when you flag the minus outside, it's not going to change the sign here. So it's really not going to change anything in the overall answer. So you can just treat this like 1, and you can just treat this here like 1. If n was 3, it'll be minus 1. When you flag the minus outside, it's basically the same thing. It's not going to change anything. So that's going to end up with minus this here, plus this here, and it's going to end up with 0 at the end. Yeah, and our next one then. And the next one you had to do, which you all could try, but I'll show you what you had to do to get it. So we did one by sine and one by cos. So the next things you could get a sine by a cos, which should be the same as a cos by a sine, because multiplication is commutative. So it's the same thing here. If you do a sine by a cos, you do have to show them a cos by a sine, kind of redundant. 4 by 2 is the same as 2 by 4. You can end up with 8, regardless. So the next combination you can have is a sine by a cos. Then you can end up with a sine by a sine, and then last you can end up with a cos by a cos. This is why Miss don't bring this question, because it's very long to do. And it have a part B in itself, and it's 8 o'clock. So you're seeing why she's kind of reluctant to bring these types of questions that give people beans. All right? But you still need to know about it. But anyway, so the next few, you'll try the cos by sine. I'll just show you how to reduce it down. It's already 8 o'clock. So you have because remember you can't use numbers, you have to use indexes. So just use n and m. So it could be cos n pi x on L. So that'll be like fn of x. And then you have sine m pi x on L. So that's the two things you want. And the same idea, integral minus L to L. So it'd be cos n pi x on L by sine m pi x on L dx. So you have that. So you're trying to integrate a product of two things. Anytime you want to integrate a product of two things, I'm going to just retellate, right? Is a compound angle. I'll go repeat. Anytime you're trying to do a product of two things, when you're integrating, it's a compound angle. It's a compound angle. Yeah, it's telling it. So you have two types of compound angle, right? Anytime you're struggling in class with a compound angle question is the same way to derive it, no matter what you do. So when you look at the product, think back to your compound angles. Which compound angle had a cos and a sine being multiplied by each other? Sine. Sine A plus B. Sine A cos B. Cos B sine A. Cos sine that we're looking for. And then the other one, if you had cos and cos, so sine and sine, which compound angle had just the both of them being multiplied, like cos, sine, sine? it will be like cos. Yeah, cos A plus B is equal to cos A, cos B minus sine A, sine B, sine, cos, cos. Like I said, we'll know which one to choose. So I hope all is in. Most likely that look with you. So if you have cos and a sine, you have to use the component rule, rewrite this, then integrate. So I'll go and show you that, and look at do it for homework and see if you get zero. You should get zero though. All right. So let's go. So how to derive it? You just write the two component angles. So let this be A and this will be B. Right? That's for derivation purposes. So it'll be sine A plus B, and you have sine A minus B. You had to use both of them, right? So this will be sine A cos B minus sine B cos A, I believe. I think it'll just flip the letters. Could be wrong. If I wrong, let me know. Sine A cos B and this yeah, sine is the same. Right. So the plus sine B cos A. So the mistake I made there is for sine, the sine inside here is always the same as what in between here. For cos it does invert, so you have to remember that. So if there's a minus here, this would be a minus here also. Essence for same. So plus plus minus minus. Just be careful with that. So what you have to do now, which one you want? You want cos by sine. You want cos A sine B. So cos A sine B. Did I write this here? Can I write it in a weird way? That's one thing. You want this here. Can I write it in a weird way? Right? So, because this way the cos was not the sine after. I don't want to confuse you, so I'm just gonna write out. I really don't want to confuse you. Okay, get confused and pass. So sine A cos B plus cos A sine B. And this one it could be minus cos A sine B. Right, much better. So you can clearly see what I'm looking at now. So what you want this cos A sine B. You want this piece here, right? So you have to get rid of this here. So to get rid of this here, send this plus and this plus, it is minus. So you get a subtract for everything. Yeah, so you get us end up with on this side sine A plus B. Oh, sorry, yeah, A plus B minus sine A minus B. And it will be equal to, so this going to cancel, like 1. So plus plus, it will be 2 cos A sine B. And when you do a little derivations and fling down the next side, you fling the 2. So it could be divided, and you get end up with a half sine A plus B minus a half sine A minus B. This is the trig ratio for this one, right? And obviously, if you wanted sine A cos B, which you would need because it's kind of redundant. Okay, if you do cos by sine, it's the same as sine by cos because multiplication is commutative. So you wouldn't really need this per se, depending on how you write this. If you write the sine first and the cos after, you will need this piece. What I mean, you don't have to do it for both. Remember, you don't have to do sine, cos, and cosine. Redundant at that point. So with this one here, you could try this the other way, which you ever do. So you just, if you want to like cos, or a sine, you can use the cos. So it could be cos A plus B, cos A minus B. And yes, I used to do this in my exam because she had show a way, I'll show you the way that she not the way, the thing to remember it by. So it'd be cos A cos B minus sine A sine B. This one, the sign is inverts. So it'd be cos A cos B plus sine A sine B. All right, so if I want cos, I'll get rid of the sine. If I was sine, I'll get rid of the cos. Kind of redundant at that point. So let me say in the other combination, we need a cos by a cos, right? So you can say cos n pi x on L, and you can multiply by next cos in the zeta function. So it could be m pi x by L. Yeah? So let's say we had that. So when you integrate it now, it will be cos by cos. So you'll end up with the integral minus L to L of cos n pi x on L by cos m pi x on L dx. So you have a product of two cos. So you just write down these two, the plus and the minus. So you want cos, so you have to get a sign, right? You have to get rid of it. So you have a minus and a plus. How you just get rid of a minus and a plus? You can minus, but if you minus, you're gonna put minus sign minus. But if you plus, it will cancel. So you plus with everything. So on this side now you end up with, I'm gonna skip some steps. So we're gonna get plus on this side. So and then you're gonna end up with 2 here. So this should just end up being cos A is supposed to be now sine B here, not cos B. Yeah, right. So cos A, cos B, whatever we have, whatever we want with this go is equal to a half cos A plus B and plus a half cos A minus B. Right? So the trick is if it's a cosine is a minus in the middle, and if it's cos, a plus. So you could just redo this for all of them. But if I were earlier, if you carried, remember like little stuff, just remember if you have a product or two, just write down if it's sine cos, you have to use the signs. If it's cos or sine, you have to use the cos compound. Do it out, write it. If I want to get this, I'd eliminate this, derive it up so you can see that you get any correcting and then use it after. Yeah, just know where you have to do. It will save you time. But if you make a mistake with remembering it, you will kind of shoot yourself in the foot if you realize after the exam it was a plus instead of a minus. So what I just do under the pressure, I just sit down and derive it, take my little minute, write only two things, subtract it, do my little transposition and get my final answer like how I get it here. And I use that. So I'll be using this here. So all you need to do now is just write back what A and B is from up here and factorize the x. Because remember that way different respect, just factorize the x out of both of them. All right, so I'll just show you one. That's one, right? So after you do, let me use this one here. So again, I'll put cos A will be n pi x on L plus m pi x on L. So be n pi x on L. Yeah, so you end up with that. So it'd be like a half the first piece. So for this piece, what I mean by factorize the x, you can end up with n plus m on L by x. That's what I mean by factorize the x. So when you differentiate the x here, you just end up with n plus m taba pi, the pi, taba pi. Let's write in the pi here. Yeah, taba pi. Yeah, taba pi. The pi is a constant, so you really got much of anything. You care about the x. So when you differentiate the x now, so the differential of sine is cos, differential of cos is minus sine. So you end up with minus a half, and you have sine, and you have this piece inside here. And the only piece that we missing right now is the reciprocal of this piece here. So you can actually write that in first, but small thing. All right, you see now. So it will be the reciprocal. So L n plus m pi. And obviously you can go ahead and multiply it out. So it'll be 2 n plus m by pi. And you have here sine and the same thing inside. I hope I seeing how long this does take. Right, so that is one piece after integration. Now you're going to do the same thing for the other piece. Remember, is 2, you're going to put cos A plus B, and you have cos A minus B. You're going to do the same thing with the next piece. And then when you do that now, you have to do the big brackets with the two of them after you plug in with the minus L to L. And then when you plug in L into both of them, remember, you will have the plus here and then the next piece, just like this here. You just end up with the minus here instead of a plus. So it'll be one is plus, one is minus. When you plug in the L minus the minus L, you should end up with 0. But the thing is, you will get 0. But you see how much work you went through? All kind of integration, compound angle, and stuff for just one piece of a question. hopefully realizing that if you bring this question, you're going to take a while to do it because you have to do it for every single possible combination of functions. You have to do it for 1 by cos, 1 by sine, cos by cos, sine by sine, sine by cos. That almost 4. And the last 3, yeah, they use compound angles and then integrate. And that does get complicated real fast. Because cos cos, compound. Sine sine, compound. Sine cos, compound. And you're seeing with the compound after you do that, you ain't integrate yet. After you integrate, the thing looking weird. Just remember you're just factorizing the x and the constants will stay. So it shouldn't be too confused with that. Right? And then after you start to plug in the intervals, and then you still have to get equal to 0. And then you start to do for the next one. So I'm gonna tell you all this question. The reason why I should let it bring it, it's long and people don't like it, right? It was pain when you have to do it, right? And I showed you all how to do the scaling. So the scaling now, same idea. I think I'll just do this one so you all can actually see. So it don't matter which one you pick, so you could just say n pi x on L. If I use a n, it would just work for any index in the group. It really matter what it is. That's why I use a letter. One, n could be 1 from to a million, but it don't matter. It go work square. So this will be all squared. So this is cos squared basically, right? So kind of adding the square just to remove the square. So it'll be cos squared, and you have a trig ratio for cos squared. So if you're not too strong with your trig ratios, you should get strong, especially for Fourier, because it is needed. So you have this, and the second one you have is cos 2 theta, or 2x. It's cos squared x minus sine squared x. So you want this, but you have to get rid of this. But you could use this to get this to plug it back into this. So what I mean by that is with 1, yeah, let's say 1 minus sine x. When you fling that minus, then you get 1 minus sine squared x is equal to cos squared x. And if fling the 1 across, you end up with cos squared x minus 1. So that minus sine. So then you plug it back into cos 2x. So you end up with cos square x plus cos square x minus 1. So you end up with cos 2x is equal to 2 cos squared x minus 1. And then when you transpose for cos square x, you can end up with cos 2x plus 1, and it does divide everything by 2. I'm going to put my laptop to charge. All right, you're back inside. So yeah, so you end up with this for cos. See, in our question, let me see. It wouldn't be plus. I mean, I'm gonna check it because I most likely make a little mistake. When I say it wouldn't be plus, when you, I'm gonna check and see if I make a mistake anyway. So sine square plus cos square, when you carry the minus, it will be minus 1. Let me make sure I have a minus 1, right? I have a minus 1 there. Then minus sine square, when you plug it back into this, you're going to end up with cos square minus 1, which is here. This will be 2. And I'm making cos square x is subject to the formula. So when you carry across minus, when you get plus 1. Which line are you talking about? I'm not sure if I see what you're talking about. Which line?
Uh,
The
Number one, where it have 1 minus sine squared x equals cos squared
1
x.
1 minus sine squared is equal to cos squared x. Let me see.
Yes.
If, uh, if it be minus 1,
No. Okay, and I'll see it. And I'll see it. All right. Cool.
all right, well, okay,
Yeah.
no problem. No problem. I'll okay see it. All right, no problem. Yeah, so if I see any mistakes, let me know. Because I am also human like you, so I could make mistakes. All right, but anyway, in the course it has error carry forward, so you see, just make sure your steps laid out properly. That means you understand where you go. Because I can tell you, I make real mistakes in my midterms and stuff, and I still did real good because miss does it error carry forward. So if I make a little arithmetic mistake, a plus instead of a minus, and the mistake is followed straight through, you'll get marks. Yeah, you do real good. Yeah, because I got A plus in the course and I make mistakes. But once your method is laid out, it's good. Especially probability. That one too is that one is P. Anyway, so where was I? Right. I've cos square x. So we're gonna plug that back into here. So again, I'll go and pull out the half, right? Because a constant. I hate constants. So cos 2x plus 1 dx. And guess what? We ain't integrate yet. If you thought we integrate, we ain't integrate. Yes, all we do is change it into a form that we could integrate it. So again, up with our half integral minus L to L, right? Why am I writing now? Back, let's integrate. Bro, things is sleeping, let's get into it. So, like, put a big square back at one time. So, the differential as sine is cos. So, if I integrate cos, I will get back sine. So, before we do that, let's just plug back in what x is before we mix it up. So, x is this piece here. So, it could be 2n pi x on L. Let's plug that back in there just to make sure. Right. I mean, I could have worked the x with it, but I like to see it. So that piece there could just be the reciprocal of it. So differential sign is cos, so it would be L on 2n pi. Remember the x that we're integrating, which is different with respect to. And then it'll be sine 2n pi x L, and the integral of 1 is x. And between minus L. Now we had to plug in L. So if you plug in L into this, now let's look at it. So L here, I'm gonna zoom in. I really feel like writing all them lines. So when you plug L into this, the L's will cancel. Where you're gonna end up with sorry, N index by 2 by pi. But remember, for sine, it don't matter what it is. 1,000 pi, 999 pi, it can be 0 regardless. So it really matter if I multiply by 2. And I can change it. Right? So that means there's a whole thing here gonna be 0. So for the first piece, when you plug in the L, this piece here for x, that's gonna end up with a half L. So that's the first piece. So now we add a minus. I had to plug in minus L, but the same thing, it don't really matter. When you plug into L into this here, the L's will cancel. You go have the minus, that's okay. The minus could go outside, that's okay. But you're still gonna end up with 2n pi, which gonna give you 10 pi, 15 pi, it really matter, pi. You're still gonna end up with 0. So it's still gonna be 0, right? For this piece here. But when you plug minus L into this, you end up with minus L here. So you just end up with a half. You can remember the half outside here, right? Or you could have leave the half outside and either way, yeah, like get the same answer, right? So there's a plus, minus, and a minus is a plus. And a half plus a half is 1, I believe. So again, I put L when you finish. So it's not equal to 0. So it is orthogonal, right? But that's what we want. We want the constant to scale it by. So just like I said before, I could just tell you what the answer is. The answer is 1 and square root of L. That's the answer. So you just show them the little proof. So why does do I just do the proof? Because the asking if the constant, and I just show them. So it could be the same thing. We go from minus L to L, and it'll be 1 square root of L. In this case, not pi is L. And what we had cos squared 2n pi x on L. And that being, that is it. Because you already square. So I'm not putting the squares yet. Right, so we have that dx. So now when you bring down the square, you're going to put 1 on L here. So you can fling that outside. Minus L cos squared 2n pi x on L dx. And the cool thing about it is you know what this integral is. Okay, you did it before. Why would you use another one for the orthonormal? Because I already did the Saturn integration for this one. You can do it again or use sine square. No, let's use the same thing. So that there is what L. So you're gonna put 1 on L. multiply by L. L and L will cancel, you get 1. So therefore, the factor that I had to scale it by, which I cannot tell it, be by the law I show you, is just 1 on the square root of L. And that is it. And that's our question. So when you're doing any orthogonal question, the same thing for number 2 with the exponentials is the same thing. She say 1, 2, 3, 4, 5, 6, where you could do, I think it's plus or minus, I think. So start from like -4, write out the series, go up to +4, and go ahead and write in the stuff, right? But you could just use just pick 2 n by m, do your integration, and get your answer at the end. Still gonna end up with 0. Same idea. I don't think she asked you for the constant. So that's just a row. It could be for that one, it could be a minus and a plus. Remember, it's plus or minus, right? If you read the questions, plus or minus. So you gotta do a minus and a minus and a minus, and a plus and a plus, and show all of them equal to 0. And then you could state it orthogonal. The set is orthogonal because any two functions you multiply, you can get 0. So I will repeat for number 2 with the E for the orthogonal question. Since you said plus or minus for the indexes, you had to do a minus and a plus and a plus, a minus and a minus. You could just use the numbers for that one. Okay, it really really matter if you use n and m. You can just use the numbers, right? So I will send you all what I did for that question after, because I did that question already with my previous class. So I'll send it to you so you can see it's kind of the same thing. Right, but I will do this number. When people ask me about this, but it's the same thing. You multiply 2, all the combinations, integrate, get 0. Some of them are compound angles in it. You use it. If it's sine, or cos, you know which compound angle you got to use. My advice is write the two of them, derive it in front of your face so you can see how you get it. Okay? If you memorize is a minus and you go in the exam and you carry them out to derive it and you just stress them if it's minus or plus, your bottom is grass. Okay, you don't know. And you will really kick yourself after. So know how to derive it, at least from first principles. So you do that, get a 0, orthonormal, you do the square, pick one, square, get it not equal to 0, so you have to get it equal to something. Then now, if you want to know what you have to scale it by to end up with 1, most of the time it's just 1 is square root or whatever the answer was. Alright, if the answer a little more complicated, like 2a on t or something like that, you're still trying to, it can be end up with the same thing. 1 in the square root or 2a on 2t, the same thing. It's literally the same thing. So that is stress out too much. It doesn't work for most things. Because all in all, you're just trying to cancel one of them, trying to cancel it to end up with this on top here. That's really all you're trying to do. Yeah? And that is it for orthogonal. For everybody who wants me to show you all how to do it. All right, so y'all have any questions on it? All, anything, anything, no matter what it is. So, okay, so you take away, make sure you know your compound angles, make sure you know the two, the basic one, multiply by 0, the square one, segue into the orthonormal and practice the integration, and you'll be good. And the integration will help you with the Fourier, with the graphs. Anyway, let's look to start the other one, which I wanted to do. So here what I would do, right? Because the exam is Wednesday, I will show you all how to do the questions. Um, when again can if only once Tuesday night, I could just come and pull a Zoom and we could just go through the proofs and whatever. Or I could go call well, let it do good in the first one for you. And then if you do good in the probability now, it will set you up nice for your finals. So you don't have to push too hard. And the good thing about the finals is the same thing and get back again. So it's not really not anything changing it. The next additional topic that she gonna bring in the finals is vectors, which is the last topic. There's three, Fourier, probability, and vectors. And she might kind of scrape down some of them topics in vectors because she noticed how people interpreted this here. But anyway, let's just start the graph question. So I may not have time to do like the actual integration bit now, but I want to do a question that I feel. But that question, I can tell you, real long and real complicated. If I try to do it that here with you all, at 8:30 in the night, well, you're gonna get real vexed up. Yeah, but what I will do, I will show you how to think about the question. Okay, if you know how to do the question, as I say, it just go and boil down to integration, and that going to take long to do. And I can tell you, when they go in the exam and they doing that integration, and you have to turn a page and you have to write over the line, it's going to get real frustrated. I can tell you that from now. So get accustomed with being under the stress, integrating and having to change the page and have to turn back constantly. Some of them write to nobody course. Say probably nobody stress when they do the Fourier and you had to change the page. So it's not easy. Sorry, not that not the word. It's simple but long and it's complicated. But it's just integration by parts. But anyway, let's just start. So when you're doing this, you're gonna work with the trigonometric form of the Fourier series, right? So you know that f of t is a naught and 2, which is a DC component, plus the sum from n is equal to minus infinity to infinity. AK goes with cos 2 pi k f naught t plus theta k plus the sum n is equal to minus infinity to infinity of bk sine of 2 pi k f naught t plus theta. So it's a trigonometric form of your Fourier series, right? So when must give you your graph, right? I'll go into the tutorial so you can see how she does bring it. So see if I give them a Chrome. All right, so here's the tutorial. Right, so top these questions, everything have a different interval. But what I want you to remember is we did these already last week. You'll be able to mash up these now. I went through everything. Everything on you should know what if she bring a cos or any combination, you all should know how to mash up that. Surely everything minus the cos square, the cos cube, the cos, the compound angle, the two part. Surely every trick on the book that Mr. Try and throw out. And it's the same thing. I show you to get the spectrum, the double-sided, everything. You should be able to mash it up and get a good better marks. Just make sure you know what you have to do, right? So when it comes to the graph questions now, if she don't give you the graph off rip, meaning that she didn't draw it for you, say how to draw it, remember this is a periodic function. And we know a period, right? 0 to t, we know that is a period, right? Or 0 to 2 pi. That's a period. Remember this. Remember this. 0 to t, period. A period, um, theoretically, is just if you have a pattern, so S, S. The interval in which the S exists, that is a period. Okay, just the time it takes the pattern to repeat itself. You could start your period from anywhere. It don't really matter what it is. It literally doesn't matter. But I just find starting the period from 0 to t nicer. But you could start the period from anywhere. It don't matter. It literally doesn't matter. Right? But I like 0 to t because 0 is a nice number. The thing that's cancel and you can clearly see what 0 multiplies 0. When you do like minus pi on 4 or minus t to t and it'll just because now you have to calculate two things and I want to do more wood. So anyway, I'm gonna show you what I mean by that. So for this one, a and minus e. So this one going from 0 to t and then from minus t to 0. So just here a line. So I like to put my 0. So this is minus t on 2 here. And this here is t on 2. And I go and go more. This is t and this is minus t. So your period is from 0 to t. So you're going to have a piece where it's have nothing. So I'll show you what I mean by that. So with respect to what I gave you, from 0 to positive t on 2 is a. So if you draw the y-axis, so this will be you here, a. And you could probably do the dotted line to show it ended. So that a. Then from 0 to minus t and 2, I'll draw the negative y-axis, is minus a. So like this, that there, minus a. There's a and minus a. So with respect to this shape here, how she gave you all it, your period will be from here to here. Yeah, but if you start from 0, you will just end up with half of it. So you might want to shoot yourself in the foot. So you could just start from here and integrate to here based on how she gave it to you. All right. So this is what she gave it to you here. So let me just extend it out so you can see some. So this is 0. So you have t and you have 2t here. So I'm not going to care about the negative piece. So from 0 to t is a. Should not draw it so big or one more space. So I'm going to shorten that t and 2t and 3t, 4t. Right, so how about the space? So from 0 to t, right? So half of this would be a t and 2. So you end up with a here. And then for the rest, from t on 2 to t is nothing. And then from t now, remember this is like at the end of the first piece. But remember the pattern, it had a negative piece here. So I got to put this piece here now. You can have, but let's go into, that would be 3t on 2. Yeah? So from here now, it will be the negative piece. And then they had the positive piece for the next half. And it just going to keep repeating over and over. And this is just going to repeat over and over. Okay, using the fact that 0 to t is a period. So you're going to just start over from t. And the pattern is going to repeat itself again. So basically, this t here will be equivalent to this piece here. From t to a half a t, so that'll be 3t on 2. And then from that piece on to 2t, nothing. And then add 2t, you add the negative again, and it just go and keep repeating itself. Because 0 to t is the period. That is the pattern. Nice. I wanted to catch that. Because once you have the periodic signal, you can integrate after. And as I said, you don't need to start from where Miss give it to you. You could start it from anywhere. Yeah, so I'm sure that I want to draw it a little nicer so you could see. You should be able to catch it. So I'm gonna draw it up here. I'm gonna go somewhere with space. So I'm gonna go to my whiteboard. So it don't really matter what let's give you. It's still gonna be a periodic function. It should really matter. Anyway, so all right, so here's this nothing, all right, and then it starts over again. So it'll be underneath now, which is the minus a, and then it on top. And then go again, and then go again, and then go again. It's the same pattern that's gonna be happening over and over and over. So this piece is gonna be underneath and on top. It is gonna happen over and over. It don't really matter. It literally don't matter. All right, so that is sketching it. It don't really matter what method it to sketch. Just do that piece and see if it have any others. That's going through all. But just to understand it, just remember a period is from 0 to t or 0 to 2 pi. Same idea. So that is the first one, which is this here. The second one is a sine function from 0 to t and 2. So that one straightforward. So this one starting at 0. And this is sine. And we know this is pi. And this is 2 pi, which is a period, which is good. So now I'm going to set from 0 to t and 2, which is the same as pi. It will just be half a t, right? And then from t and 2 to t is 0. So basically what you're trying to tell you is that this second half that we write here, it doesn't exist. So it's just this piece here. So I'll just use the numbers that she gave. So instead of it being pi and 2 pi, it will just be t and 2 and t. So just this one here and nothing. And then just like I said before, at t, the pattern just go and continue. So we go to t to 3t and 2. And then from 3t and 2 to 2t is nothing. And it just go and repeat over and over and over. Yeah, it's the same thing. It doesn't change. Right. This one here is a straight line. 2a on t by t is a straight line going from minus t on 4 to t on 4. So it's the same idea when you do that. So what I like to do is write a period, so 0 to t. So t on 4 is basically like pi, so t on 4 right here and then minus t on 4 here. And it's a straight line. Sorry, it's a straight line. So t on 4 is this here, and then you have this here. So it literally just gonna be, and if you wanted to know how something will look, especially a straight line, just plug in 0. So I plug in 0 into this, is here. So you know it can cut here. And after that, I don't really care about anything else. So it just gonna go like this. Yeah, and that is it. And then from T on 4 straight up to T, it have nothing because it never specify what going on in the rest of the period. Yeah. And then from here now, the pattern gonna repeat itself. So it didn't start from T, it start from a quarter. So it'll be 5T on 4. And so it's starting at here. And it just gonna repeat the same pattern with it going through. And you just go ahead with the same pattern over and over, never to change again. Yeah, same pattern, 0 to t is a period. So you can literally just write 0 to t, 2t, 3t, 4t, and write in little spaces in between and just draw about the same shape over and over. And you just get a periodic function from there. So t squared is a quadratic, right? And this one it's symmetrical. So minus t on 2. And then you have t on 2. So it's t squared. So it should just look like this, right? Because that's t squared. And t squared tend to be symmetrical. 1, 2, 3, 4, 5, 6. So it should just be like that. If it's minus, it should be plus. So I don't really agree to just being like that. But all in all, that's how it will look at the end of the day. And you're just gonna keep on drawing the pattern after that. But all in all, she may not bring the periodic function like this. She just might bring the graph form of it, right? So let's run through that quick and we go bust out. I want to come back Tuesday to do a question though, because it's almost 9 o'clock. So what I'm gonna follow free to run through. All right, so let's run through how it does do the questions and call it a night. Right, so steps, quick. So I know we type. I know we type, because I type too. So the first thing you look for is if it's an even or odd function. Right, that's the first thing you look for, even or odd. And it's very simple to know something even or odd. So after you sketch the graph or whatever it is, so let's say we had a normal sine function. It really matters. Sine function. Simple sine. Right? So for odd function, if x is here and you have minus x here, if it's an odd, it have to be the negative of it. So it'll be f of x. Yeah, so it'll be minus. So you have a negative f of minus x. So if you have a negative x, it'll end up being the minus of it. Right? So if you, what does do, you just continue the pattern. Just on the line itself, just literally just continue the pattern as it was going. So this here will end up going down like this and coming back up and going back here. Either just continue the pattern. Just continue the pattern. So now we're using the y-axis here, and we're using this law across the entire period. I can't stress that enough, right? Because what Mrs. do, she just kind of bring shapes. If it does do it for one x value, it might move for the others, because that's what she said odd, and it neither odd nor even. So she just kind of catch people with that. So when it continue the pattern behind the y-axis, assuming that she didn't draw it for already, it does pick some different values and check to see if it obeys the law. So for x, it's going up to let this one, right? And minus one. So one, I'm right across minus one. Okay, no problem. Find our next one. If we try here, I'll do it on this side. Here, going up to here. So expect it to go down to the other piece, negative, no problem. Go across the entire period. So this here is x. So there's negative one here. Expect to get one, one. And your period finish at minus t. So this here is zero, and that is zero, and the period done. Once you do it across one period, you know it's just going to repeat for all the other periods. Because a period, you do not care about all the rest of periods. You just care about one period. You're working with one period. It don't matter where you start the period. You just know you just care about one period. Right? I just like to start mine from zero. I like to start it from zero. So for the even, I just continue the pattern behind zero straight up to a period where there's 3 t or 2 pi, go straight back, and I just literally just look at it, find all the different types of values straight up to the end of my period on both sides, and I make sure it will be one of the laws alone, to have no exceptions. Once one point gone off, it no longer holds. So if it obeys this, it even. Sorry, odd, sorry. And if something is odd with the same Fourier series thing that you're going with, so if it's odd, so AK, let's go with cos. Cos even. BK, let's go with sine. Sine odd. So if it's odd, that means you're not gonna have any AK terms. Okay, it's not even. Alright, and then that's how I remember it. And the second one though is if you have a cos graph. So cos does start. I like to start my thing from zero. So what I'm gonna do is continue it behind my back. So you end up with that going on there. So now same idea. This is t or 2 pi. Depends on how much give you all the interval in. And I just find my different x values. So he go into here, he go into here, they go in there, they go in there, here go in here, here go in here, here go in here, here go in here. So I notice across the entire period, it's obeying a law. And the law that it's obeying is f, if this is x here, f of x will be the same as f of minus x. And this is for even function. Yeah? So as I said, so basically we have here, it mirrored it, perfectly mirrored. Yeah? So f of x is the same as f of minus x. So that's why it is start from zero, continue behind the zero, and literally check and see what we're gonna more points. Straight up across a period. Make sure it's across a period. It might have a point that she put there that's not the same. So she kind of trick you up with that. Right. So, and then obviously if it even, you have no BK term. So if it even BK will equal to zero, and should I say for all K. Right, I think I put that for the first one. For all K. Right, so it have no cos terms and this one have no sine terms. So that is just get marks for this. And how does this help? It is that you only have to do one set of integration, so that do two. All right. Assuming that is not both even, sorry, neither even nor odd. What I mean by that is if you realize that when you're doing the calculation to know if it's even or odd, and you realize that you have a point that making it not even, and you also have a point that making it not odd, well, guess what? Neither even nor odd. And guess what? You have to calculate AK and BK. So you have to do the integration for both of them. It's pressure. All right. But if you notice that it even, BK is zero. If you notice it's odd, AK is zero. So you kind of half of the amount of integration you're doing. Right, so that is one. Note if it even or odd. The second thing you do is you calculate the DC component. So to calculate the DC component, I have a equation. So I think it's 2 1t integral from, so you can say t0 to t0 plus t, which is a period for t dt. Or if it's geometric, you just find the area and divide it by 2. That's what it is. Just find the area. So if it's a square, side by side, do your thing, like A naught divided by 2, and that is your DC component. Yeah? So that's the second thing you would do. So this one involves just getting the equation of the line number f of t. Here is basically just whatever graph it is. If she give you the graph by the lines, you will actually calculate the equation of the line in between the pieces. Let me show you what I mean by that. So you kind of have an idea when you're practicing. So like we said, this going up to here, and this coming down to here. Let me just continue the pattern in the next side, coming down. Let's say it's actually going up. Okay, I don't know how the pattern will look. So in this case now, you notice across the period, it's it even. So pow, 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 so it even. So if it even, bk is 0, so you have to calculate ak. So that's good. So you kind of see it now. But for a naught and 2, right? This is a geometric shape, which is a triangle. You will have your height. You most likely never give you like a number for the height. And you should have the width, but you will have the values, whether it's in terms of pi or t. So you could get a half a base by a height, or you could find the area of one of these triangles here, multiplied by 2. However, it does do your geometric shapes, same idea, right? So I'm telling you, if it's a geometric shape, just find the area. If it's like a sine function or a cos function, well, you gotta integrate. You can run away from it. But try as much as possible to run away from the integration. Yeah? So with this one here now, if you wasn't doing geometric shapes, you'll have to get the equation of this line and integrate with respect to 0 to t and 4. And you gotta get the equation for this line and integrate it from t and 4 to t. Yeah? And if you forget, I will speak slow. If you have to get the equation of a line, you need the y-intercept and the gradient, or you need a point on the line and the gradient. And if you have a point on the line and a gradient, you're just using this form, y minus y1, this mx minus x1. This was work good when you have the gradient m and a point on the line, at any point. And this will generate your y-intercept and everything for you. Real easy. This is one of those used mostly, because if you have the graph, you can just use the point where it ending, which in this case will be t on 4 and a, and that will be a point, and obviously you could get the gradient, because if it's starting from 0 and you know the end point, you could do a y2 minus y1 divided by x2 minus x1, and you get m. Plug it in this equation here, you do a little transposition to solve for y, and you get the equation that you like. You just get marks all. You will really see what the y-intercept is, but obviously you can see the y-intercept here is 0. So you could just calculate the gradient and plug it in. But if you're not seeing it, you could always trust that you can do this. Once you have a point in the line in the gradient, if you're seeing it starting from 0, you can just go ahead and do that. All right, so where was that? So that is A naught on 2. If a geometric area divided by 2. If it's not, you integrate the pieces in between the intervals, and you go ahead and do your integration and add it up at the end. It is long. And then if it even or odd, it will depend, that will determine whether you're doing AK or BK, which is the integration for it. So that's the reason why most of us go through the even or odd to know which one going equal to 0. If none of them equal to 0, at that point, just cry. Because I real integration I had to do. If you do that, she wicked. Like real wicked. Like real wicked. Because that means like two set of integration you had to do. Alright? So I went through odd, even, the DC components. Right, the next thing I had to do is do the integration for AK or BK, depending on which one had went to zero. So you should know the equations AK 21T, T0 to T0 plus T. Anytime I see miss do that, it just means across a period. So AK just goes with cos. So F of T 2 pi K F naught T dt. So I believe that is AK, and then BK, if you didn't know, it's 21T integral across a period F of T, and BK goes with sine. So sine of 2 pi K F naught T dt. So depending on which one you have, you calculate AK and a BK. Yeah, and then at the end of all line integration, that'll be the end of your question. Right? So last thing, 2 minutes. So after you do all the integration and stuff, and if she asks you to plot spectrum, it's the same idea. Right? So when you're plotting spectrum, remember in this you're gonna end up with any trigonometric form. So if it's in a trigonometric form, you have to convert it to the harmonic form to get the spectrum as the same little equation you learned before. So CK square root of AK squared, so squared is on top, AK squared plus BK squared. But the cool thing about it, whether even or odd, one of these things gonna be zero. Yeah, so if it's odd, AK gone, so it's just square root of BK squared, which is just BK. And if it even, BK gone, so it's just the square root of AK squared, which is just AK. So you could get your magnitude spectrum from this. Right? And then for the phase spectrum, which is your theta k, and that is minus tan inverse BK on AK, right? But the cool thing about it, assuming that the function not neither odd nor even, meaning like don't have a AK and a BK equation to index. If BK is zero, you're just gonna end up with just the same phase for everything. Because zero divided by something is just zero. So tan inverse of the same thing, it's just gonna be the same thing for everything. So I think tan inverse as zero is zero. Tough. So you're not gonna really have much of a phase spectrum for, so if BK was zero, that means it even, right? And if it's the other way around, type problems because the bottom piece will end up being zero. And that means you're going into infinity and beyond. But what I like to do, and an easy way to look at it, so this is BK and AK. So for all your points, right? If all your BK values are zero, right? That means you only have AK values. So all your points gonna lie on the AK line. Different magnitudes, but it literally just gonna stay on the AK line. So your phase gonna always be 0 degrees because it's not deviating from the x-axis. It's always gonna be 0 degrees. And that is when BK is zero, which is basically when the function even alone. Contrastingly, if the function just odd alone, it have a, meaning AK is just zero, that means all the lines gonna be just on the BK axis alone. It's not gonna have a AK components. So since all of them on the BK line, all the phases will just be 90. So you're gonna be minus 90 because they're not deviating from this. So all of them just gonna be spoke, minus 90, minus 90, minus. Yeah, that's all of them gonna happen. They're gonna all have the same phase. All of them. Because one of them zero. But if both of them not zero, you actually get a different phase depending on what BK and AK is. Right? And that is the end of the question. You should be able to get the double sided if she asks, but she really asks for that. So all in all, the summary of it, I don't want to keep on it too long. Even or odd, a DC component, after a DC component, AK or BK, after AK and BK, get a spectrum. One of them will be zero. If not, you gotta index both of them separately to get where AK and BK terminals. So like if K is one, if K is one, you have to calculate where A1 is, A B1 to get C1, which is square root of A1 squared plus B1 squared. You do it for 2, 3, 4, 5, 6. You get A and B to get a magnitude spectrum. Then for your theta case, same idea. B1 and A1, plug it in the equation and you get the different phases. That is assuming that they need a odd or even. If it even or odd, it's kind of easier because you know it's either going to be 90 or 0. And that is it. Everything else from there, as I say, is just going to be you practicing how to integrate. That's all that is. And the same thing for where f at t. If it break up into pieces, this way it's not geometry. You have to break it up into pieces. So if there's a set of straight line and curve and thing for each change, you just integrate the different piece. All right, and I will end it. I don't want to keep it too long. All right, so you'll have any questions and anything I did here? Anything? All right. If no questions, I did have videos on this on the YouTube channel already with the questions I did from last time I did the course. So you could check those videos and I did the whole integration question and stuff. So you could check it out, but let me know if you're all free Tuesday night to run through a question and the proof and stuff. Otherwise, I'll just send my proofs. You should have it. I'll send the proofs and stuff in the chat on the drive so you all can read it through. So make sure you know the proofs. Trick to harmonic, trick to exponential. Make sure you know the little equations for AK, PK, CK, because she will ask you those stuff. Make sure you know how to convert your cosines and your sines and all that. And make sure you know this here. And you'll be good for your midterm for the first one. Alright? Other than that, you all could go ahead, 'cause I don't want to keep all too long. Thanks for coming out and showing the figure to pass, and we'll go through. So we'll talk next time. So next week, starting probability, because I want to stay with her. But for the finals, we have more time, so we can actually do longer questions and stuff. But otherwise, stay safe and we'll talk.